Okay, 3, 2, 1. Exponentials and logarithms. Shut up. Okay, this is fucking stupid.
Keep going.
Okay, so if you have an exponential, x to the a equals y. So you have this. I can't do this. I'm so bad at it.
That's right here.
No, like I know what I'm talking about. I just can't keep it. Like,
Oh.
you have an exponential, y equals x to the a. So the thing about this is there's two inverse functions to this graph. So that's because there is 3 total variables instead of 2. Well, 1 usually isn't considered a variable. The a can in fact change. So the two different inverses to this function is a logarithm and then a square root or any root. So the square root is used to find specifically the x, while the logarithm is used to find the a. So, I don't know, that's all I got.
I mean, keep going.
I don't have any. So logarithms, they are in the form of logarithm base, which is the x, and then in parentheses is the y, which equals a. And then square or roots are specifically exponents that are to a fractional power. So they can be used to find the x because when fuck. I'm trying to think.
We're just gonna cut out everything that you're thinking.
I can't even read that with these glasses on.
Oh. Do you need glasses?
No. These glasses make my vision worse.
Oh.
They're for the look.
Okay.
But yeah. I don't know how the fuck you do this. How do you keep a fucking straight face? And how do you just talk?
You BS it. You BS all the way through.
I can't BS this shit.
Do you like examples? Like,
Well, I'm trying to fully explain this stuff.
if A equals this and X equals this, then the graph would look like this, and you draw it.
Okay, so logarithms can be used to find specifically the exponent or a, and roots can be used to find x. So I'll explain how logarithms work. Roots work as a fractional exponent because when you have an exponent like x to the a and you put that whole expression to an exponent, then the two exponents will multiply. So if we have a fractional exponent on the outside, a to the power of 1 over a, then it'll just become x to the power of 1. So therefore,
Properties.
you can find x.
Properties too. The properties of the logarithm.
I don't want to explain it. Those are really annoying. I hate them. So yeah, so the expression x to the a to the 1 over a is equivalent to y over y to the 1 over a. So if you find y to the 1 over a, you find x individually. That's roots. Okay. So
Yeah.
you want me to explain log properties?
Yeah. I mean, they're right there.
No, I want to try and remember them, see if I know them. I think I do.
You can also explain like the shape of these graphs.
No. Why would I do that?
An exponent's like that. A logarithm's like that.
They can understand that.
What's the root then?
What's a root?
Yeah. Like that.
Yeah. Okay. Log properties. So if you have, let's think. This has been going on for 5.5 minutes. I know you're disappointed, Matthew.
A little bit. I mean, you're the one who knows this stuff.
Well, I'm trying to, like, explain it verbally.
Well, like, just take the info.
I'd be a really bad teacher. So if you have, let's say, the natural log, so the base of the log is just e, or Euler's constant. If you have the natural log of, let's say, x to the a equals some b. So that means, so log properties would imply that b would equal a times the natural log of x. Because whenever you have an exponent in what the natural log is operating on, it can be brought out front of the natural log, or specifically any log. Or why not? Damn.
I'm keeping this part of the video in.
No. It's my memory card. I can keep it if I want to.
Continue.
Okay, more log properties. So if you have, I'm just gonna use the natural log as logarithm, because it's like the most common logarithm you'll find. So if you have natural log of A plus natural log of B, log properties imply that you can combine that into natural log of A times B. So whenever there's addition between two logarithms of the same base, then you can combine them into one logarithm and multiply the two things that both logarithms are operating on. So, what's the last one? I know the last one. And then the last one is, if you have a logarithm of base A and it's operating on B, then you can split that up into two logarithms and you will get log base x. It can be any number. So as long as the two logarithms are the same base, it can be any number. You can change it into log base x of A, or log base x of B over log base x of A. Boom. And all of these different properties just derive from the properties of exponents. Like addition like comes from multiplication and exponent. I don't know what I'm fucking saying.
Okay, now they explain the properties of like roots.
No.
No?
It's the same as exponents.
Oh, I didn't know that.
Because roots are just exponents. You know?
I guess so. I didn't know that.
They're fractional exponents.
We didn't do roots. We did like just exponents and deponents. And
Deponents.
Deponents are exponents that go down. I don't know. It's just
Negative
exponents.
exponent?
Yeah, negative exponents.
Yeah.
Is that it?
Yeah, pretty much.